We are still in Module 13. We are still working on radical expressions or understanding what a root is. And today we're going to talk about what happens if we do not want to write it with a root symbol. We want to write it instead with an exponent. Remember, roots and exponents go hand in hand together. So we're going to talk about rational exponents today. So if you go look at your class notes, please. Let's just refresh our memory. We've seen exponents all semester. We know a positive exponent. We know 4 squared means take the base 4 and multiply it twice. So 4 times 4 is 16. So we understand when exponents are positive. We've also learned about negative exponents. So if I have that expression in our notes, 4 to the negative 2, we know that it makes no sense. How can you write the base 4 negative 2 times? So we've learned a trick. We've learned to work with negative exponents. You do the reciprocal of the base. So you would flip that base 4, you'd make 1/4, and then the exponent becomes a 2. And we understand 1/4 squared. That means 1/4 times 1/4. So we have learned the only time we work with exponents is when they're positive whole numbers. Well, now if you look at my next expression, I have 4 to the 1/2. There's a problem with that. That exponent's not a whole number. It's a fraction. So we got to learn, what does it mean if your exponent's a fraction? Well, that physically means write the base half times. Well, you can't take a number 4 and write it half times. So we're going to learn a definition. And in your notes it says, every exponent that's written as a fraction can be changed into a root. And that's how this ties into this chapter. We're dealing with roots. Roots and exponents go together. So if you ever see an exponent that's a fraction, you're first going to rewrite your expression as a root. So when I have 4 to the 1/2, what that really means I'm asking you guys to do is a square root. That number in the denominator, that 2 in the denominator, means square root. So if we look, we're going to go to our examples. It says here to find the value of each. We're going to work each of these examples out. If you look, each of these examples has an exponent, a superscript. But each of the exponents is a fraction. So you've got to learn how to rewrite these as roots. So let's go to the board. This says 64 to the 1/2. What I'm teaching you today is very simple. If you see an exponent that's a fraction, you rewrite it as a root. What root is this? The denominator is always the root. This is the square root. We don't put the 2 there, it's understood. What are we square rooting? 64. This numerator is still the exponent. There's a 1 there. Now, do we have to write a base with an exponent of the 1? Absolutely not. We all learned this just means the square root of 64. Now we can work it out. We understand that. What is the square root of 64? 8. Same thing here. If you see an exponent that's a fraction, your first job is to change this to a root. Half, the exponent of half means square root. What are we square rooting? The base, negative 64. That 1 is still the exponent. Do we have to write an exponent of the 1? No, we do not. So I'm asking you to do the square root of negative 64. What number times itself is negative 64? That doesn't exist. So what do we write? No real root. Look here. I have an exponent. It's a fraction. It means a root. But it doesn't mean a square root this time. That denominator is a 3. What root do you think that is? That's a cube root of 64 to the first power. Again, denominator is always the root. The numerator is always the exponent. So this is the cube root of 64, and that is not 8. What number do you multiply 3 times to give you 64? That's 4. 4 times 4 times 4 is 64. Again, I have an exponent. It's a fraction. Any exponent that's a fraction, you change into a root. This is the cube root of negative 64 to the first power. I don't need the first power. So this is a cube root of negative 64. What number do you multiply 3 times to give you a negative 64? That has an answer. That would be negative 4. A negative times a negative times a negative. Cubing means 3 times. That would give you a negative. Now, this is the one that scares me because I know what happens. You see the fraction 1/8, you see the fraction 1/3, and you automatically start singing, multiplying fractions is no problem. I am not asking you to multiply these together. If I was asking you to multiply these together, I would have written 1/8 times 1/3 side by side. So you've got to pay attention. This 1/3 is in the exponent spot. That means we change this to a root. What root? The cube root. So I'm asking you to do the cube root of the base. What's the base? 1/8. The exponent stays a 1. So I'm asking you to do the cube root of 1/8. But we've already discussed this. This means you're cube rooting both the numerator 1 and the denominator 8. What's the cube root of 1? 1. What's the cube root of 8? 2. So that value is 1/2. Okay, we have one more. This last one is tricky because now if you look at the exponent, it's not positive, it's a negative. So we're going all the way back to chapter 12. Chapter 12 said you do not ever work with negative exponents. They don't make sense. How can you write this base negative 1/3 times? So we still got to use the rules we learned before. There are no negative exponents in math. You always make an exponent positive, and how do you do that? You do the reciprocal of the base. What does reciprocal mean to do? It means to flip the base. So we're going to flip 1/8. We're going to write 8 over 1, and now that exponent becomes 1/3. So rules are rules. I taught you in the other modules, never keep a negative exponent. Make it positive first by doing the reciprocal of the base. Once you do this, the exponent is positive. Now, yes, it's still a fraction. So that means to you this is a root. What root is this? We're doing the cube root. The denominator is a 3. We're doing a cube root. What is 8 over 1? That's 8. And what's still the exponent? 1. So I'm asking you to cube root 8, which you guys all know the answer to that. That is 2. So the moral of the story is this. Anytime you see an exponent that's a fraction, you're going to rewrite the expression as a root. Let's look at our notes again. Now, all of those were very similar that we just did because if you look at all those examples, with the exponent, all the numerators are 1s. Let's now look at our next set. Here is 8 to the 2/3 and 4 to the 3/2. Now the exponents are not 1s, they're 2s and 3s. The rule is the rule is the rule. Every time you see an exponent that's a fraction, you have to rewrite this expression as a root. The numerator of the fraction is always the exponent, and the denominator of the fraction is always the root. So that's very important to keep that in mind. So let's go and look at our next set of examples here. Okay, if you look, all of these examples have exponents that are fractions. Yes, I know you can go type this in a calculator and get an answer, but then you'll not understand what the calculator's doing. So to understand this, we're going to go through the process. Okay, I have 16 to the 3/2. That tells me, oh no, I got an exponent that's a fraction. I got to rewrite this as a root. So what root is this? The denominator is the root. This is a square root because the 2. What's my base? 16. What's still my exponent? 3. So this is read as the square root of 16 cubed. Now the question is, which one do you do first? Do you cube 16 first, or do you square root it first? Well, if you don't have a calculator, cubing 16, we're going to be here a while, because 16 times 16 is 256. Then 256 times 16 is a very large number. So I'm going to tell you, you do the operation you read first. This says square root of 16. What is the square root of 16? That's 4. Then you're going to take it and cube it. So what you've got to understand is there's 2 operations going on here, a root and an exponent. So this is a 2-step process. 4 cubed is 4 times 4 times 4, which is 64. Let's do the next one. I have 27 to the 2/3. What does that mean? The root is cube. So I'm asking you to cube root 27 and then to take that answer and square it. Sure, I can get a calculator out and do 27 times 27 and then try to cube root it, but it would be easier to do the root first. What is the cube root of 27? You all have memorized that. What multiplies to give us 27? It's 3. Then you'll take the 3 and square it. So what's 3 times 3? 9. Very simple. The next one, 16 to the 3/4. That means we're going to do the 4th root of 16 cubed. Even though we didn't make a list, we can all think about this. What is the 4th root of 16? What number do you multiply 4 times to make 16? That would be 2. And 2 cubed would be 8. So 8 is your answer. We have -8 to the 4/3. Again, what root am I asking you to do? The denominator is the root. We're doing the cube root of -8, and then we're going to do it 4 times. So again, the root is easy to do first. What's the cube root of -8? -2. -2 times -2 times -2 is -8. But then we got to do that 4 times. So if you take a negative and multiply it 4 times, you're going to get a positive, and 2 4 times is 16. Our last example is, what happens if the exponent's negative? It goes back to the beginning of the semester. We never work with negative exponents. You always make your exponent positive first. How do you do that? The rule we learned months ago. To make a negative exponent positive, you do the reciprocal of the base. What does reciprocal mean to do? It means to flip this base. So this is 8/1, right? So we flip it, the 1 would go to the numerator, the 8 would go to the denominator. Now I know there's a negative sign, but do we ever bring the negative down? Nope, it stays in the top. All that does is make that exponent positive. Now, we're going to rewrite this. If you have an exponent that's a fraction, you rewrite this as a root. So this is the cube root, the base is -1/8, and then it has an exponent of 4. The denominator is the root, the numerator is always the exponent. We always do the root first because it's easier. What would you multiply 3 times to give you a -1/8? Well, that would be a -1/2. And then we're going to do that 4 times. So we're going to do -1/2 times -1/2 times -1/2 times -1/2. Oh my, we're back to fractions. Multiplying fractions is no problem. Top times top, bottom times bottom. 1 times 1 times 1 times 1 is 1, and it's going to be positive. 2 times 2 times 2 times 2 is 16. So to work with exponents that are fractions, you've got to understand they really mean roots. Catch you in the next video.